Ah, the internet. It connects us all in ways we never thought possible. But behind the scenes, there's a lot going on that we don't see. It's a bit like a grand bustling city. Data packets are whizzing about like taxis, all trying to get to their destinations. And just like a city needs traffic lights, the internet needs protocols to keep everything running smoothly. One such protocol is IGMP, which stands for Internet Group Management Protocol. Imagine you have a group of friends who all want to watch the same live stream. IGMP is like the organizer who makes sure everyone in the group gets a copy of the stream. It does this by managing something called multicast traffic. Think of it as a way to send data to multiple recipients at once, without flooding the entire network with unnecessary copies. IGMP helps routers figure out who wants what and directs the traffic accordingly. So the next time you're enjoying a smooth streaming experience, remember to thank IGMP. It's working hard behind the scenes to make it all possible. Now, let's delve a bit deeper into this multicast business, shall we? Imagine you have a juicy bit of gossip to share. You could tell each of your friends individually, but that would be terribly time-consuming. Wouldn't it be much easier to simply announce it to the group and let everyone hear at once? That's essentially what Multicast does. It allows one device to send data to multiple devices at the same time. Think of it as a radio broadcast. The radio station sends out a signal, and anyone with a receiver tuned to the right frequency can pick it up. This is quite different from unicast, where data is sent from one device to another, like a private phone call. Multicast is all about efficiency. It reduces bandwidth consumption and network congestion by sending only one copy of the data across the network. But can multicast function without IGMP? Well, technically yes, but it wouldn't be pretty. IGMP acts as a sort of moderator, making sure the data only goes to those who have specifically requested it. So while multicast can technically exist without IGMP, it's not a practical solution. We've talked about IGMP and its role in managing multicast traffic, but how does it actually work its magic? Well, this is where IGMP Snooping comes in. It's a clever mechanism that allows network devices like switches to listen in on the conversations between devices and routers. Think of it as a discreet butler who eavesdrops on the guests' conversations at a party. The butler doesn't participate in the conversations, but pays close attention to who's interested in what. Similarly, IGMP Snooping allows switches to keep track of which devices are part of which multicast groups. Without IGMP Snooping, the switch would blindly forward multicast traffic to all devices on the network, even those that aren't interested. This would be a huge waste of bandwidth and could slow down the entire network. IGMP Snooping prevents this by creating a sort of multicast forwarding table. This makes the network much more efficient and prevents unnecessary congestion. Now you might be wondering, if IGMP Snooping is so great, why would anyone ever want to turn it off? That's a valid question. For instance, in very small networks with minimal multicast traffic, the benefits of IGMP Snooping might be negligible. Disabling it could potentially free up a tiny bit of processing power on the switch. However, I must caution against disabling IGMP Snooping unless you have a very good reason and a thorough understanding of the potential consequences. Section 5. The downside of multicast. Too much of a good thing. Multicast, as we've discussed, is a brilliant way to send data to multiple recipients efficiently. It's like baking one large cake instead of many individual cupcakes, much less effort for the same result. However, like all good things, multicast can be a bit much if overused. Imagine if every single piece of information on the internet was sent via multicast. It would be overwhelming, wouldn't it? The network would be flooded with data, and it would be difficult to find the specific information you need. That's why multicast is best suited for specific applications where one-to-many communication is essential. Things like video streaming, online gaming, and software updates benefit greatly from multicast's efficiency. For everyday web browsing, email, and other unicast applications, multicast would be overkill. Section 6. Do routers even use multicast? We've talked about IGMP and multicast in the context of switches. But what about routers, those tireless traffic directors of the internet? Do they use multicast too? The answer, my friends, is a resounding yes. Routers are the masters of directing traffic between different networks. They're like the postal service of the internet, ensuring that data packets reach their intended destinations. And just like the postal service uses different methods to deliver letters, parcels, and bulk mail, routers use different protocols for different types of data. Multicast is one of the tools in a router's arsenal. They use it for a variety of tasks, such as routers need to be able to forward multicast traffic between different networks. Some routers act as multicast servers, providing content like video streams to multiple clients. Section 7. Potential issues with IGMP snooping, uninvited guests. IGMP snooping, as we've established, is generally a good thing. It helps keep multicast traffic in check and prevents network congestion. But like any system, it's not entirely foolproof. There are a few potential issues that can arise with IGMP snooping, mostly related to unexpected or malicious behavior on the network. One such issue is the IGMP snooping storm. Imagine a mischievous gremlin sneaking into our party and starting to spread false rumors about which guests are interested in which conversations. Similarly, a malicious device on the network could flood the switch with fake IGMP messages, claiming to be part of numerous multicast groups. This would overwhelm the switch's IGMP snooping mechanism, causing it to malfunction and potentially disrupt legitimate multicast traffic. Thankfully, most modern switches have mechanisms to mitigate these risks, such as IGMP snooping query election and rate limiting. Section 8. Is IGMP snooping a security risk? The mention of malicious devices and security risks might have you wondering, is IGMP snooping itself a security vulnerability? The answer, thankfully, is not really. IGMP snooping on its own doesn't introduce any inherent security flaws. It's like a lock on your door. It's there to protect, not to harm. However, like any security measure, IGMP snooping can be bypassed or exploited if not properly configured, or if the network itself has other vulnerabilities. For example, if a malicious device gains access to the network, it could potentially exploit IGMP snooping to eavesdrop on multicast traffic, or even inject malicious data into the multicast stream. So while IGMP snooping isn't a security risk in itself, it's essential to maintain overall network security to prevent malicious actors from exploiting any potential weaknesses. Section 9. Is IGMP snooping on by default? Now, you might be curious about whether you need to enable IGMP snooping manually, or if it's already up and running on your network. The answer in most cases is that IGMP snooping is typically enabled by default on managed network devices like switches. It's like buying a car with airbags. They come standard for your safety. Manufacturers understand the importance of IGMP snooping in optimizing network performance and preventing multicast-related issues. So they usually enable it out of the box to ensure a smooth and efficient network experience for users. However, it's always a good idea to double-check the configuration of your network devices, especially if you're experiencing any network performance issues or suspect that multicast traffic might be the culprit. Section 10. Conclusion: IGMP, a silent guardian. We've journeyed through the intricacies of IGMP, multicast and IGMP snooping, uncovering their roles in the grand orchestra of the internet. IGMP snooping, our discreet butler, plays a crucial role in this orchestra, intelligently directing multicast traffic and preventing network congestion. While not without its potential quirks, IGMP snooping is generally a beneficial mechanism that contributes significantly to the smooth operation of our networks. So the next time you're enjoying a seamless streaming experience or participating in an online gaming session without a hitch, take a moment to appreciate the silent guardians of the internet. IGMP and IGMP snooping, working tirelessly behind the scenes to make it all possible. Section 11. One last thing. As we conclude our exploration of IGMP, it's important to remember that the internet is a constantly evolving landscape. New technologies emerge, protocols are refined, and our understanding of network management continues to grow. IGMP and IGMP snooping, while essential today, might evolve or be complemented by new mechanisms in the future. So stay curious, keep exploring, and who knows what fascinating technologies await us in the ever-evolving world of the internet.